Have you ever stopped to think about what's actually holding our modern world together? You know, the car you drive, the buildings you're in, the phone in your hand. It's not just the nuts and bolts we can see. There's an invisible force, a really transformative technology that's become a critical, load-bearing part of pretty much everything we build. This is the story of structural adhesives. So here's what we're going to get into. First, we'll look at the old way of putting things together and why it's kind of broken. Then, we'll introduce the hero of our story, the structural adhesive, and get into the science of its superpowers. After that, we'll see how it's already creating a lighter future. And finally, we'll take a look at what's coming next for this incredible technology.
For literally centuries, we've depended on things like rivets, bolts, screws, mechanical fasteners, and welding, of course. We trust them, they're familiar, but the truth is they've got some pretty serious limitations that just don't work for the demands of modern engineering.
Okay, so here's the fundamental issue with the old school methods. When you use a rivet or a weld, you're focusing all the physical stress of the structure onto these tiny little points. That creates built-in weak spots right from the start. Adhesives, they do the exact opposite. They spread that stress out nice and evenly across the entire bonded surface. And that simple difference, well, it's a total game changer for how we design things. Here's a really great way to visualize it. Think of a rivet like a stiletto heel on a wooden floor. All that pressure is focused on one tiny spot, right? It's just asking for a crack or a dent. But a structural adhesive, that's more like a snowshoe. It creates this continuous, wide area of contact that spreads the load out evenly. The whole thing becomes so much stronger and way more resistant to breaking down over time. So, now that we've seen the problem, let's meet the solution. And listen, we're not talking about the craft glue you have in a drawer somewhere. We're talking about a whole new class of material that doesn't just stick stuff together, it actually cures and becomes an integral, permanent part of the structure itself.
And that's the key thing to understand. A structural adhesive is engineered to carry a load. It has to handle shock, crazy vibrations, extreme temperatures for the entire lifespan of the product. It doesn't matter if it's a car, a plane, or a wind turbine. It's not just an add-on, it's a core component.
This one idea right here shows you just how powerful these materials are. Let me break that down. It means if you glue two pieces of metal together with this stuff and try to pull them apart, the metal itself will stretch, bend, and break before the adhesive ever gives up. The bond is literally stronger than the materials it's joining. That is a massive shift in how we think about engineering. So, how does this magic in a tube actually work? What gives these adhesives their superpowers? Let's dive into the chemistry for a second, because it's what lets engineers create materials with these very specific, absolutely incredible abilities. Right, so not all structural adhesives are created equal. They come in a few main flavors, each with its own specialty. You've got epoxies, which are the undisputed heavyweights, the champions of strength and heat resistance, perfect for things like aerospace. Then you have acrylics. They're all about speed and convenience. They cure super fast and stick to almost anything. And finally, you've got urethanes. Think of them as the flexible heroes. Great for toughness and handling a lot of movement and vibration. And the advantages go way beyond just raw strength, because you can use them to join totally different materials, like say aluminum to carbon fiber. They open up this whole world of design that's just impossible with welding. They also act as an electrical insulator, which is crucial for stopping something called galvanic corrosion. That's the nasty rust-like decay that happens when certain metals touch. And let's be honest, from a design standpoint, you get these beautiful, clean, seamless surfaces, no ugly rivets or weld marks. Okay, so where is all this amazing science being put to work? Because this isn't some far-off lab experiment. It's already out there, building a lighter, stronger, and more efficient world at a massive scale, in the very products that shape our daily lives. You can see right away the automotive industry is the biggest user by a long shot. The constant push for lighter, safer, more fuel-efficient cars, especially with EVs now, makes adhesives an absolutely essential tool for engineers. But you can also see it's critical in renewable energy, modern building construction, and even in high-performance sports gear. Electric vehicles are a perfect example of this in action. To get the most range out of a battery, every single gram matters.
Adhesives let car makers build bodies out of a cocktail of lightweight materials. They also make the car's frame stiffer, which is a huge deal for crash safety, and they're absolutely critical for putting together those massive, complex battery packs. Plus, as a bonus, they make the ride quieter by soaking up vibrations. And the impact on how we manufacture things, it's just staggering. I mean, picture a classic assembly line, drilling thousands of holes, lining up panels, putting in countless rivets. Adhesives can replace a ton of those steps with a single automated process. And that's why some manufacturers are reporting assembly cost reductions of up to 50%. That's a huge gain in efficiency.
And it's not just cars. Think about the challenge of building a modern wind turbine blade. We're talking about structures that can be longer than a football field. They're made of composite materials that you just can't weld. Structural adhesives are literally the only technology that can reliably bond these huge components together and survive the incredible stresses they're under for decades out in the wind and rain. But the story doesn't end here. This field is not standing still. This invisible revolution is actually speeding up, with chemists and engineers constantly pushing the limits of what's possible to meet our next big challenges. All that innovation is driving some major growth. The global market for this stuff is projected to hit nearly $18 billion by 2029. Why? Because every industry is demanding products that are lighter, stronger, and more sustainable, and adhesives are often the key that unlocks that possibility. That number is basically a massive global bet on a future that's built with glue. And the future of adhesives is just fascinating. There's a huge push for sustainability, developing new bio-based glues from things like plants and agricultural waste instead of fossil fuels. Companies are using AI to design brand new, custom adhesives in a tiny fraction of the time it used to take. And we're getting these hyper-specialized products that can be both incredibly strong and super elastic at the same time, solving engineering puzzles that we used to think were impossible. So, from the car you're in to the clean energy we need, this foundational technology is already the invisible backbone of our world. As it gets smarter and stronger and greener, it just makes you wonder, what new doors is it going to unlock? What incredible things will it help us build next?